You guys are on top of it. You guys are on top of it. Thank you for catching that. Should be good to go now. So today we're going to be talking about exceptions. I'm going to talk about the online course changes, as well as just briefly mention that we still don't actually have a full plan for the exam, but some homework stuff that's coming up to be aware of. So with that, first and foremost, let's just get right into the announcements. So thank you again. If there's any other audio issues, certainly don't be afraid to let me know. I assume everything's fixed now because people aren't spamming muted anymore, but please don't be afraid to spam muted when I'm muted. So first and foremost, the announcements. Let me move these around. I have to move them around for each slide. So first, there won't be a quiz this weekend, just because this is the only class that we're having this week. We will pick back up with the Monday, Wednesday, Friday schedule next week, starting again at noon as always. The homework for due date, because we've lost a week effectively of office hours, it has been updated. It will now be due April 1 at 11:30. The exam 2 has also been rescheduled, and it will now be April 3rd. We don't yet have a firm picture of what the exam is going to look like. We will try to clarify that certainly by the time of the exam review. We do recognize, for example, that time zones are a factor. We recognize, of course, that internet reliability could be a factor with some students. So we will do our best to handle those kind of on an ad hoc basis. By the way, no one said anything. I assume my audio is working, but if someone could type like the bald guy speaks or something, then that would help me out. I apologize for the lighting. So, all right, good. I apologize for the lighting right now. It is bright outside my window. This won't be a problem starting Monday. I'm actually in the process of moving. That box is the box my computer is going in right after this lecture. So I will be uh, able to have a better presentation. I'll have a whiteboard set up and all that at my new place. That way I'll be able to lecture effectively there. I apologize for the random lighting changes on my camera. That should get better. Are we going to submit these slides on Colab? Well, I have good news for you. Um, they're already there. So if you go on to Colab, let me pull up the full screen. If you go on Colab right now, um, you'll see under Java code example. Oops, sorry, I'm actually on the wrong Colab right now, believe it or not. We have multiple. So I already have the slides up for today. In addition to that, I already have the code that I'm going to show you up for today. And I'm going to make every concerted effort I can to continue, because I've done this out of habit, but I'm going to continue to do so. Continue to get code up before class starts onto Colab, as well as the slides. So I will do the best I can to that end. So again, the exam will be April 3rd. We don't yet know exactly what that's going to entail, but just we'll talk about that on the exam review day. Please do bear with us, as we were as prepared for this change as the rest of you, which is to say we weren't prepared. And we're doing the best we can to kind of play catch up here. So today we're going to be talking about exceptions. And an exception is short for an exceptional circumstance or an exceptional event. So this is to say that the program is trying to do something that it either shouldn't be able to do under normal circumstances, or it cannot do under normal circumstances. So the program, generally, when an exception is thrown, it crashes. An example of how I can generate an exception fairly quickly, just to demo this real quick, is going to full screen share here. I can just create public static void main string args. I can just create an array very quickly. 5, 4, 1, 2, 7. And if I try to do system.out.println array, let's do 7. By the way, please let me know if this screen quality is not great. I believe I'm streaming at 1080p, so please let me know if that looks okay. Could you increase the volume? So I can't, and the reason is that I'm already yellow barring, and if I start red barring, it's gonna kick in the compressor, which makes it sound horrible. All I can say is I would suggest turning your volume up. If you don't know, by the way, down here there's a volume mixer. Right click. Hang on. Right here on Windows, there's a volume mixer, and it could be possible that you have Twitch turned down or your browser turned down. Sorry, I don't want to kick on the compressor because then it will just sound absolutely terrible for everyone. So this is how we can generate an exception. There we go. Java out of bound or java.lang.array index out of bounds exception. This exception means I tried to do something that I can't do. I can't access this array at index 7 because an index 7 doesn't exist. And whenever that happens, the program crashes and it does not continue. So I do not print hello here. Now, hopefully what I'm showing here is not new to anyone. You've probably run into this in your own code. Sorry, my cats are just going absolutely insane because we've been moving things, so they're all panicked. It's time for their midday run around the house like animals, which they are, in fairness. So I never print hello here because the program crashes on this line. When you crash, don't pass go, don't collect $200. But there's a way to avoid exceptions. Specifically, doing something called a try catch block. And specifically, what I am going to try to catch is an array index out of bounds exception. Out.println, we caught the exception. And what this does, this try catch block, is it will try to execute this code. But if this code crashes at any point, it will see if I have caught the exception. Specifically, this array index out of bounds exception. From here, it will no longer crash at this point. So to illustrate that, when I run this program, notice it prints we caught the exception, and now it prints hello. Notice my program didn't crash. That's because while this still tries to crash, I caught the exception, and I handled it. That is to say, I did something besides let the program crash. Now, to be clear, the reason this array index out of bounds exception catches it is because I need to specify exactly. Great question, Pudge, and you're exactly right. I need to specify the exception type. And now this does use inheritance, but for example, another exception that you're probably all familiar with, I'm sure it's everyone's favorite exception, is the null pointer exception. If I change this to the null pointer exception, who doesn't think it's a good day when you see a null pointer exception, Kappa? Kappa is, by the way, if you're not familiar with Twitch, Kappa is an emote that generally denotes sarcasm. Thank you for demonstrating. So null pointer exception is not the same as an index out of bounds exception. So notice now that I'm trying to catch a null pointer exception, what happens? Now, my code. By the way, I apologize if you can hear my cat Colby meowing. So now notice the program still crashed, and it's because the exception that I caught, the exception that this try block threw, was not a null pointer exception. It was an array out of bounds exception. Show the cats. After lecture. Let me get through the material first. So, all right, that's enough emote spam because I actually do want to make sure that I can see questions if they come up. One or two emotes is fine. It's getting a little extreme. Anyway, so the point here is this try catch block tries to do something. If it throws an exception, that exception is caught and handled by the catch block, and that prevents the program from crashing. The next thing I want to show is the finally block. And the finally block runs no matter what, whether we crash or don't crash. System.out.println. Let's go with Kappa, since people seem to like that emote a lot. Now if I run this program, you will notice that before I crash, it says kappa. And if I change this back to array index out of bounds exception, now I'm going to catch the exception again. Now you'll notice that kappa also prints. So what is happening here? The point of finally is that finally always runs. Whether or not we catch an exception, whether or not we crash, or whether or not we finish the try block without ever generating an exception, finally will always run. What does the E? So this is a bit weird. What happens is if we catch this exception, E actually is a placeholder variable that is of data type, array index out of bounds exception, and that will hold information like the stack trace when the exception is generated. Oh, there's Stuart, by the way. That's Stuart. He's my buddy. So just to start over, I wasn't expecting my cat to jump up. Array index out of bounds exception E. This is a variable, and you can actually do stuff with E, like E dot print stack trace here. So what happens if an exception occurs in the final? He just I apologize for this. He just jumped into the box that I have ready to put my computer in. So that's what that noise was. So what happens if it crashes and finally? Let's find out. Let's do null.toString. Hang on. I'll do it this way. Object O equals null O.toString. This will crash. This will crash with a null pointer exception. Just to show what happens, it actually crashes because of a null pointer exception, because it crashes in the finding block. Now this is where I caught the exception. If I change it to where I don't catch the exception, let's change this into a file not found exception, which is another type of exception. Oh, sorry, I have to import that. Oh, that's right. I can't do this one. Let's do a legal argument exception. Also, my cat Colby might jump up here in a second. So, at this point, where I crashed was still inside the finally. What happens if a caught exception is thrown in the finally block? It does not catch it. So, just to illustrate that, null pointer exception. So notice it did not catch the null pointer exception generated at line 12. So the catch block only catches things inside of try. If you have two try catch finally blocks, will both finallys run before a crash? No, not necessarily. It depends on where the crash occurs. So for example, if I did it like this, where I have like two try catch blocks, if the code crashes here, we never hit this finally block. If the cache is in the second try. So the first finally would have happened before we enter the second try. And, sorry. And can you put a try catch in a finally block? You can. I would say avoid that, but yes, you can. Can you pass in a generic exception that catches any type? Yes. That is exception, and we'll actually talk about that in a second. So there is a hierarchy of exceptions. So remember how we talked about object hierarchy? Remember how we talked about object hierarchy? How there's, like we can define it that every class inherits from object, and then my in-class example was I had like shape and then triangle and then right and equilateral triangle as subtrees. We have a similar hierarchy for exceptions. So let's pop on back over to the slides, take a quick look at those. So we can throw an exception whenever code does something it shouldn't. And I'm going to show some examples of when we might actually want to throw an exception here in a bit when we go into the bank account example, which you can start taking a look at now if you want to download it from Colab. Generally, the idea of throwing an exception is to make sure your program cannot be used incorrectly. So the idea is, generally, when an exception occurs, the Java virtual machine, which is the thing that is running your code, will terminate unless you have caught it, unless you have some type of try-catch block. If you're inside a try and you catch that exception, it will do that instead. But otherwise, it tries to crash. And failing a catch statement, it will crash, it will end the program. And the point here is to end your program in a meaningful, useful way that enables you to debug your code. This is why we actually have an exception when you go index out of bounds. Because here's the thing. If you're working with some older, more primitive languages, if you try to access an array out of bounds, it actually won't crash. What it will do is it will access just whatever memory address happens to be outside of the array, and whatever's stored there will get copied in. That ends up being significantly harder to debug because instead of crashing, your code just does weird stuff, and it's hard to figure out why. So crashing is, in a way, a good thing in this respect. So the syntax of throwing an exception, and I have an example of this in a bank account code, so I'm just going to go ahead and pull that up real quick. The syntax of throwing that is to do something like, let's say you try to deposit a negative amount of money in a bank account, throw a new illegal argument exception. If you are in need of multiple try-catch, depending on the implementation required, you can, okay, thank you. Yeah, you can have multiple catch statements, and I'm actually going to show examples of that later. I just, for the sake of time, I don't have, don't want to get too far ahead of ourselves. So for instance, if you try to deposit a negative amount into a bank account, it's going to say a legal argument exception. You can't deposit a negative amount. And this is actually a good thing that I'm doing this, because the point is, someone is going to be writing a class that relies on my bank account code. And it's going to have something like bank account A equals new bank account 100. So that's a bank account with $100. A dot deposit 50. Sorry, I can't spell the word deposit apparently. That would be fine, but if I then tried to do a dot deposit negative 50, well, this code will crash. And this is to make sure that whoever is using my bank account class cannot use it in an incorrect way. My intent is for deposit, my intent as a developer is for deposit to only work with positive numbers. This exception is a way to enforce that. Any questions so far about the intent of why we have exceptions? I'll give a minute for people to ask questions, but I'm also going to probably step on the gas. If I don't get to your question, ask it at the end of lecture. It's just because it's actually harder to get through lecture now with it being online. Everything's felt a bit slower for me. Can you throw a generic exception? You actually can't. You have to throw a specific exception. Can you do any functionality instead of just a print statement? So technically this isn't a print statement, this is a stack trace. So if you notice, it actually traces where my crash occurred. But that said, the only way to do something else with an exception is to define your own behavior, usually through a try-catch block. There's other things that you can do, but it's well beyond this course to talk about doing other things with an exception. For the sake of this, you say exceptions as a means to crash the program. Pardon me. Can you throw generic exceptions? So you cannot. You have to throw a specific kind, but it's always throw new exception. The reason is the class exception, because it is a class, is actually an abstract class. By the way, you can define your own exceptions. For example, here is an insufficient funds exception. I wrote my own here, and actually you don't technically need this part. This is literally all you need to do to define your own exception. What I am saying is, I want to define my own exception called funds exception. It's going to inherit from runtime exception. So runtime exception is any exception that happens while the program is running. And by the way, I'm going to get to an example of something I do besides crashing, but that involves a try-catch block. All I need to do is say, here's my constructor, it takes in a message, and I just pass that message to the parent class. But by defining my own exception, this is actually valuable. Because let's go back to that example. Let's say, so right now I have $150 in my bank account. Let's say I try to do a.withdraw 200. If I try to do this, I'm going to get that exception I just threw, insufficient funds exception. So this allows me to define my own exception, and I have my error message, withdraw amount exceeds balance insufficient funds. So this is useful because now notice the name of this exception indicates to the user of my code what caused the exception. It's not a mystery. It's because, oh, they tried to withdraw something that wasn't there. So this is the advantage of creating your own exceptions. Let's keep things on topic. Thank you. I'm sure that thing you copied and pasted from someone else sounded really clever when you were 12. Anyway, with that, to that end, we're going to now jump back into the slides. So I'm going to quickly show the hierarchy of exceptions, and let me move... Sorry, that says the hierarchy of exception classes. Let me just move me off the screen a little bit. So we have... we have this exception hierarchy here, and they all inherit from this thing called throwable. And below throwable, and I'll zoom in a bit, do a little bit of a enhance. You can see that exception inherits from throwable. From there, we have kind of three broad classifications. IO exception, class not found exception, runtime exception. Class not found has to deal with if you're trying to access a class, but it hasn't been compiled yet. You're not really going to see that very often unless you have something wrong with your Eclipse setup, so we're just going to ignore it. We're going to focus on IO exception and runtime exception, and notice they're different colors. That's actually relevant. But some examples of runtime exceptions. Arithmetic exception is generated when you try to divide by 0. Sorry, is my sound quality poor? I apologize if it is. I'm not dropping frames, but let me know if it is. Arithmetic exception is like int divided by 0. Class cast exception, this is when you try to cast to something that doesn't fit. I've actually shown this in class. Illegal argument exception, number format. This comes from integer.parseInt, for example. Index out of bounds. There's also array index out of bounds and list index out of bounds. These ones have to deal with iterator, no such element exception, so we're just going to skip it. This actually comes from scanner, excuse me. And then null pointer exception, everyone's favorite exception. Hang on, my cat is death meowing, and I don't really know why. I really am hoping I don't have to get up and deal with it. I apologize, it's very distracting. All right. So with that, going back now to the code. So if, for example, inside of my temp, if I had, say, a try-catch block, try a.withdraw, catch, if I do exception E, system.out.println, exception thrown, I sincerely apologize for the noise. Can you cats stop? I can't close the door because it just gets extremely hot in this room if the door is closed, but I think I'm going to have to just deal with that in a second. Yeah, you will not. That's a good point. You will not be expected to memorize them, but you should know the most common ones. Okay, I apologize. I can hear them. Trust me, it's very loud. Exception E. Hang on. I sincerely apologize. That was getting so annoying. So exception E is kind of a catch-all because going back to the slides, you can see that we have exception at the top. Everything else inherits from exception. So everything is under this umbrella. That's why this is a catch-all term. So there we go. Notice exception thrown. I caught it. But generally, you want to try to be more specific, something like insufficient funds exception, just because you should only catch an error when you can meaningfully do something with it, which we'll talk more about in a bit. Oh, actually, sorry, exceptions. That's why. It was a compiler error. There we go. Okay. Jumping back into the slides now, I'm going to zoom back out. I'm not expecting you to memorize all these. I just wanted to show them to say, like, you've probably seen most of these at some point. Can you have multiple catch statements with a try? Yes. And the way you would do that is something like catch a legal argument exception E. Something like this. And you can have as many catches you want. And we'll talk about the order that these need to be in later on. When you use try catch blocks versus throwing an exception. So throwing an exception is when you want to notify the user that what they're doing is illegal. Try catch is used when you can actually handle an exception. You know a block of code will generate an exception, but you want to handle it so that the program doesn't crash. Let me move this back over here. That's the general idea. All right. Going back to the slides now. So, something to note. We've talked about catching exceptions. You can catch multiple like this. I'm going to kind of move through slides, but what you want to do is make sure you're finding the best match. So, for example, different exceptions are broader. So, for example, IO exception is specific. File not found exception is even more specific than IO exception. Exception is even more broad than IO exception, and throwable catches everything. So there's that hierarchy, and it goes from the specific, which is the things down here, file not found, null pointer exception, etc. Those are the very specific. We have the broad, IO exception, runtime exception, and then we have throwable, which is the highest kind of, or throwable, which is the highest end, and then exception, which is one step below that. You should be familiar with these common exceptions and what can cause them. A legal argument exception, this is useful if you're writing a function and you want certain arguments to be illegal. So for example, if we were writing, say, public static double square root double x, we would very reasonably have something like if x is less than 0.0, throw new illegal argument exception, x can't be negative, or input can't be negative. That's an example of where I would throw an exception intentionally. What is the hierarchy between runtime and IO? So if throwable is great grandpa and exception is grandpa, then runtime and IO are brother and sister, effectively. That is to say, which one should we handle first? Well, so the thing about exceptions is because your code executes in order, whenever you hit an exception, the program will try to crash. So it will hit the first one it comes to. So IO exception and runtime exception have the same, and by the way, it's runtime exception, not runtime error. They have the same relationship that you would see between, say, arithmetic exception and class cast exception. They're siblings. They're not, this is not, arithmetic exception is not a parent of class cast. So in this case, IO and runtime are just siblings. They're brother and sister in this respect. All right. By the way, I don't have a return. This doesn't compile, but this is just an example of it. When will a runtime exception occur? So again, Runtime exception is a broad category. So an example of you get a runtime exception whenever you get a null pointer exception. Runtime exception is the parent class, and the child classes are arithmetic exception, class cast, illegal argument, index, etc. So all of these are runtime exceptions. So a runtime exception is just anything that causes the program to crash while it is running that isn't related to I/O, which is to say input output. So we'll distinguish that in a second. All right, so let me get back into the slides here. Sorry, I'm trying to position everything on the screen such that it doesn't get cut off. So when we catch exceptions, we would actually want to catch them generally in order of most specific to most broad. But what you should never do is you should never put can the program generate two exceptions at the same time? No, it cannot. Because programs execute in order, programs only do one thing at a time. But that said, remember, if you're throwing an illegal argument exception, you are also throwing a runtime exception because they're the same exception in that case because of hierarchy. So notice in this case, let's say we were trying to catch a file not found exception, and this font is not showing up particularly well. So let me try to change the color of it real quick. In this case, we're sorting our catch blocks in order of most specific to most general. So file not found exception is a specific example of an I/O exception, and an I/O exception is a specific example of an exception. So we have to put the catch blocks in this order. So if we were to try to do something else, so I can actually copy this code into what I have going on so far here. Oops, that's right. Things don't copy and paste well from PowerPoint. So let's say that I had scanner s equals new scanner new file input.txt. And this is a way to do file I/O. We haven't gone into this before, so I don't expect you to necessarily be overly familiar with it. Sorry, it's... So from there, if I try to do this, I'm going to need, and we'll talk about why Java forces this in a second, I'm going to need to catch a file not found exception. What do I do if the file input.txt doesn't exist? So something like system.println input.txt is not a file, which in this case it's not. So if I run this code, you'll notice immediately that I catch that. From there, I can do a catch IO exception E. As I can even do catch exception E. And in this case, I do need to import that exception. But notice that these are sorted in order, pardon me, of specific to vague. Java actually enforces this order. So for example, let's say I tried to move IO exception above file not found exception. If you notice, I get the red underline of shame here. So, excuse me, the red underline of shame here. This means that this code doesn't compile, and it doesn't compile because I'm trying to catch a file not found after an IO exception, but if it were a file not found exception, well, then this catch statement would have caught it to begin with, because this catch statement catches everything that inherits from IO exception, and file not found inherits from IO exception. So Java actually enforces this order, but it's important to remember that the order has to be from specific to the general. Now from there, one thing to note is if the exceptions are not in the same hierarchy. For example, catch in this case null pointer exception E. And I'm going to cut that and paste that there. In this case, you may be thinking, well, wait, but a null pointer exception is more specific than an IO exception. It is, but null pointer exception is not in the same hierarchy as IO exception. So in this case, null pointer exception would not be caught by any of the two above, file not found or IO exception, because it's in a different hierarchy. Just to quickly show that again, here's null pointer exception under runtime exception. Here's file not found exception over here. All right. So with that, are there any questions about what I've shown so far in terms of the code? And if there are, I'll give a minute for people to type it while I prepare to show off the next set of slides. While I'm doing that, I encourage you to look at the guess a number game. Ordering is only required for descendants and ancestors. That is correct. Yes, so only classes in the same hierarchy. Can you put a null pointer exception before that? Yes. I could even put a null pointer exception as the very first exception. Just to show that real quick. Why throw an exception if you can just use a try catch? Again, they're two different things. So let me explain. So I can put, just to show this, I can put null pointer exception first, and that's fine. Why throw an exception if we can just use a try catch? So the thing is that sometimes you actually want your code to crash. So for example, let's say I'm working for a bank. If I'm writing the back-end bank, yes, I apologize. I will try to mute them. Hang on. Hopefully that will mute them. Apologies for that. Hang on. Nope, that didn't help. Could we take a quick look at the in class? Again, those files are already on Colab, so they're right here on Colab. All the files are already here. The text files we download. So I actually am not doing any file I/O here. If you want to do file I/O, I'll cover it at the end of lecture. Let me get through the exception stuff for now. Yes, I'm trying to mute. Hang on, let me just. I had the Discord up because I have it set up so I can communicate with TAs, but I'm just going to turn it off because the noise is distracting. Yeah, apologies. Okay. So here's an example of when I would actually want to throw an exception rather than try to handle it myself. If I am developing bank account software, I'm setting up the limitation such that no other program can use my code incorrectly. And part of what I'm specifying is my code never allows a bank account to be negative. So if you try to pass in a starting balance that's less than 0, I'm not going to let you as a developer. This is actually going to crash your code. And even if you start it with a try catch, you won't end up actually instantiating the object you mean to instantiate. And that's intended. I want to prevent that. It is the responsibility of whoever is using my code to use it correctly, and this is a way that I can prevent you from using it incorrectly is by throwing exceptions. An example of where I do a try catch is when I want to be able to circumvent a crash. So for example, here I have the guess a number game. This, just to show how this is played, and you can download this code. It's already on the web. Guess a number 1 to 100. The number is larger. Let's try 75. Smaller, 67, smaller, 62, smaller. I know I'm not playing as efficiently as I could. Smaller, 53, larger, 54. I win. Right? This code does that game. You can play it if you're really bored. Yes, I actually did give this assignment. But here's the thing. What if I tried to type in, oh, actually, I don't have my break statement in there. Sorry? I need my break statement in there. Here's the thing. If I were to say, for example, type banana. Well, normally, if I tried to do in next int with a scanner, which the scanner is what's reading in the user file, if I enter something that's not a number and then I try to read it as an integer, it's going to throw an input mismatch exception. But because I'm catching this, So I'm catching the exception. I can then say error invalid input. I can then skip the rest of the line and force the user to try again. So the user has to try again. So this function has not returned yet. Until I enter a valid guess, it's not going to return. So if I type eat, or if I type 37.5, those are not valid entries. But the second I type 37, well, now the function works. This entire time where I typed only one valid entry now only uses one guess. So that's an advantage of using try catch. That's an example where I'd want to use try catch. All right, so now back into the slides. The rest of this lecture will mostly be slide material, so I apologize for that in advance because I know people prefer the live coding. Just to clarify what the so I mentioned before briefly that we have to catch a file not found exception. So for example, I'll go back to the code. Here I'm trying to do file IO. If I delete this file not found exception, Java is actually going to complain and it's going to be very unhappy with me. It's going to give me the red underline of shame. And the reason it's giving me this is if you hover over it, it will say unhandled exception type file not found exception. The reason Java forces you to handle the file not found exception is because it is something called a checked exception. So there's two types of exceptions, checked and unchecked. Checked exceptions are something that Java forces you to handle. You are required to have a contingency plan if a file not found occurs. You're required to catch it and do something with it. It might be as simple as you just still print the stack trace, and just to show you what that looks like, eprint stack trace, this still crashes your program and prints the stack trace. This is the default error behavior. You can change this, of course, if you want to not crash and want to try to handle the file not found exception, but you can also leave this for now. You do not have to handle, notice Java's not forcing me to actually handle a null pointer exception. If I delete the null pointer exception, Java doesn't care. It compiles fine, all the same. The reason Java allows this is because null pointer exception is unchecked. So the difference between checked and unchecked. Checked, Java, as a compiler, forces you to handle the exception because it could be thrown, such as when you're doing file IO, you have to catch file not found exceptions. If you're doing a URL, you have to catch a malformed URL exception. And then there's unchecked exceptions, which are typically runtime exceptions. And those are things that could happen because the code is written incorrectly. So things like an array out of bounds exception. Forgive me, I'm trying to... So generally a checked exception is caused by external circumstances that the programmer... I cannot prevent is too strong a word, but just to say that it is outside the scope of the program. For example, if you're building your program and you put a file in the wrong place, that's your fault. So it's not to say that checked exceptions are not your fault as a programmer. It just means that the problem with the program is external to the program itself. It's not the code in the program that caused the exception. It's the fact that the file is not there. Or in the case of a database is not there, or a database hasn't been initialized, or a server connection doesn't work. Generally, anything related to I/O, which is external to the program, is an I/O exception, not a runtime exception. And as such, it is checked. Java forces you to handle it. By comparison, and I already showed an example of this, the guess a number, this input mismatch exception, even though this deals a bit with I/O, this is still a runtime exception. This is to say that in this case, it is something that happens at runtime that causes the program to fail. Specifically, I assumed the next thing would be an integer, and it was not. So any questions about the difference between checked versus unchecked? And I'll let people type that. Just to clarify, going back to our hierarchy, everything that's in red here is checked. Everything that is in green is unchecked. What makes an exception checked or unchecked? Unchecked exceptions are generally runtime exceptions. Checked exceptions generally have to deal with I/O, input output, so files or servers. Or by the way, that's Colby Bear. Does this rule of check being external and unchecked hold 100% of the time? It's a guideline more than it is a hard and fast rule. You can have a checked exception that maybe doesn't explicitly deal with I/O. I've just never seen a reason to generate one, but that's not to say it can't be done. If you're making your own exception class, almost always if you're making your own exception class, it's unchecked. So by the way, we're not even going to make you make your own exceptions in this class. So that's not something that you're expected to do for the sake of this class. But generally, any exception you make is going to be unchecked. And that's because I'm extending runtime exception, which is unchecked. If I wanted a checked exception, I could extend IO exception, and then because IO exception is checked, this exception will be checked. But otherwise, you're just going to make it unchecked. What if you have a general exception E that covers checked and unchecked exceptions? So yes, that does count as handling. So for example, going back to temp, checked exception E. Notice that Java's okay with this. This still compiles. Java's fine with me doing it this way. So exception can be a catch-all in this case. Oh, sorry. I keep clicking on the wrong thing. So one thing is that you can add a throws declaration instead of handling it, but I'll let you look at how that's done on your own. From here, we're going to go to the in-class activity. So I'm going to pull that up here on Colab. So if you go under assignments, because we will still have in-class activity even though the class is online. Do we need to return the sum for an in-class assignment? So give me 1 second. So just to quickly show, so yeah, that's a good question. I'm focusing on Jay Mastrullo's question. So just real quick to show this, in the guess a number game, notice that I never return inside of here. So because I'm inside of a loop, the catch never results in a return. If, however, let's say I said something like return here, I still have to return a number, or I have to just let the program crash. So do something like e.print stack trace. You could return 0.0 if you would like for the sake of the in-class activity, but actually you should just if you can't, so this goes back to what I said earlier. If you can't actually handle an exception, if for example, you're taking in a sum of, or list of files and you're producing a sum, if you can't actually handle if someone says banana. So you can either skip it and ignore banana, or you can just let the program crash if you want it to. It depends on what you want to have happen. So let me actually pull up the in-class activity for today. So here it is. So you're going to download this. Sorry, I don't have the full screen up. You're going to download this file, read in data, and I'll just copy and paste it in here. And really, these are daily activities now. You're not required to do it here in Twitch chat. Read in data. So this is the class, and what you are going to do is you're going to, inside this method is a try catch block without any catch statements. Add the following catch statements. So you have to put them in the right order. And then for each print statement, give a short message describing what could have caused that exception. And then just run the main method to understand basically why that's so. So we give some sample inputs, test 2, test 3, test 4. There is no test 1, so that will generate a file not found exception, for example. So once you're done with this, once you are done editing this file and getting all the exceptions in this, because you're going to add catch statements here, once you get them in the correct order with useful error messages, just submit this file to Colab, and then that's the in-class activity for the day, even though it's not in class. At this point, I'll take any questions from any point in lecture, but I won't be presenting any new material. Notice I said lecture questions, so please no off-topic questions at this time. I'll go until noon with on-topic questions, and if people have off-topic, I'd be happy to answer them at that point. Text files go in source. No. So the text files will actually go inside the overall. So for example, here I'm going to do a new. Notice I'm clicking on the project folder, new untitled text file. This is a text file, and I'm going to save it as temp.txt, and I'm going to save it inside of exceptions. So this is where it is. It's inside of the exceptions folder. It's not inside of source. That's where they go. Any other on-topic questions? And again, I will patiently wait for them if you come across them. Yeah. To clarify, if I do not return the sum again after my catch block, Java says it must return the sum. So if I get an error message, but also the sum is printed after each one. So to clarify, let me just go to the directions here. We don't really stipulate what to do if this crashes. What I would say is that we would be fine if you just print 0. If the sum if this crashes, we're fine if you just return 0. If it's forcing you to return something, I'm okay with that. Yes. So just return 0. Can you explain a bit more about runtime and non-checked? So runtime exceptions are non-checked exceptions. So anything that's the fault of the programmer, like, for example, object O equals null, system.out.println, O.toString. This is a null pointer exception, and it's because I programmed badly. So this is runtime because the compiler doesn't catch this. Even though you and I can look at this and be like, oh, that's not going to work very well, the compiler doesn't catch this. So throwing from within a catch block, either explicitly or accidentally, out of the scope for this course. No, so you can throw an exception. So for example, I could still throw something like, let's say, file not found exception. I could, let's say this is because I actually get the file name from the command line arguments. So I have something like arg0, which gets information from the command line arguments. If this file is not found, I could then say instead, throw new illegal argument exception. And this would still crash my program, but input file name doesn't exist, something like that. This would still crash my program, but it would give me a more useful message. So it's just as simple as throwing another exception. If you just want to let the program crash, so you can catch the exception and then do something like system.out.println, hey, I caught an exception. Something like that. I could then do e.print stack trace, and this is still going to crash my program. So at that point, just to show what happens, system.out.println hello world. Oh, it doesn't, that's weird. Notice that it still, in this case, never prints hello world, and that's because eprint stack trace basically says, let the exception crash the program. It also prints the stack trace, which is quite useful, because stack traces are good for debugging, but e.print stack trace ends the program. Oh, right, no, you're right, I'm sorry. File.txt. Here, let me change it back. Oh, actually, it still did print hello world. Interesting. Sorry, I thought eprint stack trace closed the program. You can always do system.exit 0 as well. Sorry, I will say that I've never written code where I handle an exception where I just print the stack trace. If I'm gonna print the stack trace, I'm not gonna try to handle the exception. So apologies, I was incorrect there. This doesn't terminate the program. That said, Eprints, yes, exactly. Print stack trace and system exit is called by default. That is, it prints the stack trace of the program and then it terminates the program. So generally, again, if you can't actually handle an exception, if you can't do something with it, you shouldn't try to catch it. You should only try to catch exceptions when you're going to do something. Any other on-topic questions? Because I know people want to see my cats, and I will show them. Give another couple minutes for people to type on-topic questions. And I did off-topic questions last night. I'm not going to get into the habit of doing it after every lecture. So this will be the last time I do it for a while after I show my cats because people are asking for them. But otherwise, I'll do a stream at the end of the year, which is just any question that's you're interested in, whether it's related directly to the class or to computer science as a whole or whatever. Because I always like to do that lecture at the end of the year where I allow for that. So I'll do a stream for that at some point. Talk about why I'm terrified of AI at some point because I am. I'll just sit here awkwardly waiting for on-topic questions, and if there are none, you can certainly go. There's no new material being presented today. I will see everyone Monday. Stay safe. Wash your hands. Socially isolate like you are infected because you may very well be infected. And can you show a real world use for a try finally? Yeah. So the most standard example of a try catch finally is doing something like, so when you open up a file, or when I open up a scanner to read in a file, scanner s equals new scanner, um, new file temp.txt, something like that. When you open up this file stream, it actually creates a pipeline, which is pretty memory expensive. And so one thing you should do when you're done with the file is you should always close it. So catch file not found exception E. S.close. And actually, I have to define the scanner outside the try block. So something like this. This is to make sure that I close the scanner before I terminate the program. And that's because you should always close any file I/O before the program ends, just because it's very memory expensive. Also, when you're writing to a file specifically, you always need to close because that forces a flush. And if you're not familiar with that term, you can look up some stuff on file I/O. It's not really expected to be known for this class, but certainly I've done things like this. I've also, when we get to concurrency, we will get into very specific examples where you do want to use finally. What's the difference between code in the finally block and code after try catch? The finally always runs even if the try cat crashes with an uncaught exception. The code looks buggy. If the file doesn't exist, we'll call. That's a good point. Thank you, Strager. I have fixed that. My son will. He started learning. Okay. I have been casting for a day, so I'm pretty sure that's not true. Um, I will admit that's funny. But yeah, for in-class activities, printing the stack trace an acceptable print statement. Yes, yes, that's fine. I'm okay with that. But yeah, so it will actually get to when we get to concurrency, we will we will actually show real practical examples of try catch finally where you need the finally block. So we will get to that. Any last questions here? All right, so I'm going to do non-serious questions, but just to make sure people know this is over, I'm actually going to kill the stream and then I'm going to bring it right back. Um, so Yeah, finally for closing mutexes, that's exactly correct. Yes, at least one of the files should at least one of the files run correctly. I don't think we actually have any of them running correctly. I think all of them crash, and that's intended. That's by design. Um, I'm going to end this stream and then I'm just going to start it right back up. That way, this VOD is only in class stuff. So I'll be right back.